Okay, so welcome students. Um, my name is Evaristo. Yeah, so today, as I promised, I just want us to focus on the vectors. Now, the part that we are going to focus on today under vectors, we are going to focus on dot product and cross product, right? So the part that I want us to focus on today, it's the dot product. Dot product of what? Vectors. Dot product of vectors. So this is the part that I want us to focus on. Dot product of vectors. So remember, a vector is a physical quantity that has both magnitude and direction. So a vector is a physical quantity that has both magnitude and direction. Or I can say a vector, to be more specific, a vector is a quantity, it's a quantity that has both magnitude and direction. So a vector is a quantity that has both magnitude and direction, right? So now magnitude, to find magnitude, let's use R to mean resultant or magnitude. So magnitude is found by using this formula. The component of Rx square plus the component of Ry square, right? So this is how you find the magnitude. So magnitude is the same as finding the hypotenuse using Pythagoras theorem. You can imagine it in this way. Imagine we have this right angle triangle and this is the hypotenuse, right? So let's say this is A. Let's say this is A and this is B. How are you going to find the magnitude? In grade 12, you learn to say magnitude or hypotenuse equals to what? The square root of A square plus B square. All right? Or in other words, you can say hypotenuse equals to what? X square plus Y square. Because this is X and this is Y. All right? All this is coming from the idea. All this is coming from the idea to say, from this idea, when you draw the Cartesian plane, when we draw the Cartesian plane, let's say this is the y-axis and this is the x-axis, all right? So this is x and this is y. And we draw the resultant there, and if you complete it, this is the x-axis and this is the y-axis. So this is x and this is y. So if you are looking for this resultant, you are going to say the square root of what? X square plus y square. Hope you remember this, all right? So the way you find the resultant or magnitude of the vector when you have two components of a vector is the same as when you are trying to find the Pythagoras, you use the Pythagoras theorem, all right? So remember, a vector is a quantity that has both magnitude and direction. So now, I've just taught you how you're supposed to find the magnitude. The square root of x square plus y square. Now, what about the direction? Because a vector is supposed to have what? Magnitude and what? And direction. So now, what about the direction? How can you find direction of the vector? To find direction, you are going to use tan. So tan theta equals to what? the component of y over the component of what? X. So to find theta, you are going to take this tan the other side and you find the inverse. So theta equals to what? Tan inverse of what? Component of y over the component of x. So this formula helps us to find the direction of a vector, of the resultant of the vector. And this formula helps us to find the magnitude of a vector. All right? So this formula is for the magnitude, this formula is for the direction. So you must know these two formulas. You must know these two formulas. All right? So now, let's talk about dot product of a vector. Dot product of a vector. Dot product of a vector. Let's say we have vector A. Remember, a vector is denoted by what? Putting an arrow on top. All right? So let's say we have vector A. Now, before I talk about this, do you remember in grade 12 that we have unit vectors? Unity vectors. So I'm going to cover most of the things under today's lesson. Unit vectors. Remember, unit vectors, I said, we have I, J, and K, right? That means we can have this X or Y plane where we have the X-axis. The X-axis means I, all right? Don't forget this. The X-axis means I. This is the Y-axis, and it means, this is the Y-axis, and it means J. We also have another axis that means Z. So we have X-axis, Y-axis, and Z-axis. So the X-axis means I units. The Y-axis means J units. And the Z-axis means K units. So a vector can have I component or J component or K component, right? So I, J, K notations, these are unity vectors. Don't forget this. Unit vectors are I, J, and K. I stand for x-axis, J stand for y-axis, and K stand for z-axis. Don't forget this. So that means we can have vector A, all right? This vector A can be x in the x-axis, plus it can also be in the y-axis, plus it can also be what? In the z-axis. So this can be written as vector A equals to what? The component of x of A plus the component of y of A plus the component of what? Z of A, all right? Or this can be also be written as what? If you don't want to write x, y, and z, you can just AI, because I means x, plus AJ, because J means y, plus AK, because K means what? Z. So these are the units. And we write a vector in terms of what? Units. We don't say AX, AY, AZ. We say AI, AJ, AK. These are the units. Hope you understand. Don't forget that. For example, let's have vector A. Vector A equals to 3I plus 4J minus 3K. Right? Don't say vector A equals to 3x plus 4y minus, don't write like this. This is wrong. Minus 3z. This is wrong. This is how you write it. All right? In terms of units. X means I, Y means J, Z means what? K. These are the unit vectors. And this vector is in 3 dimensions. As you can see, we have 3 components. When I say dimensions, I mean components. So we have the X dimension, the Y dimension, and the K dimension. So this vector is in 3 dimensions because we have 3 components here. 1, 2, 3. If we only have 2 components, for example, vector A equals to 3i minus 4j. It means this is in 2 dimensions because we only have 2 components. Now, since we know the unit vectors, now let's try to see how we can multiply vectors. Dot product. So dot product of vectors is also known as what? Scalar product. Scalar product. Why is it called scalar product? It is called scalar product because when you multiply 2 vectors, the answer that you get is a real number. Remember, scalar means what? Number. It's a constant number. It has no units. For example, whenever you see this number 3i, this means this is a vector. All right? This is a vector because it has magnitude. It has magnitude, which is 3, and the direction, which is what? I. Remember, I, it means this one is in the x-axis. So these I, they are directions or unity vectors. All right? And this is as a result of a vector product or cross product. But dot product, it means when you multiply the 2 vectors, the answer that you get is a real number and not a vector. All right? A vector has a number and a unit. For example, let's look at vector A and vector B. Let's say vector A has 3i plus 4j. Now vector B has 6i minus 2j. Now the question is find dot product of vector A and vector B. Solution. So to find dot product, what you do is, remember, to find dot product, what you do is, you have vector A, all right? So to find dot product, A dot B, what you do is, get vector A and vector B. Now you are going to multiply the numbers with with the coefficients of I alone plus the coefficients of J alone. Then the answer that you get together, you add. All right? So to find dot product, just multiply the coefficients of I alone plus the coefficients of J alone. If we had another, if these 2 vectors were in 3 dimensions, we had k, it means we would have also multiplied the coefficients of k alone. So for example, since we have vector A as 3i plus 4j, vector B as 6i minus 2j, so we are going to multiply the coefficients of I, right, alone. So the coefficient of I here is 3 and the coefficient of I here is 6. So 3 times 6, so I'm going to say 3 times 6 plus C. Don't forget this, eh? Plus what? Plus the coefficient of J. What is the coefficient of J for vector A? 4. Right? 4 times the coefficient of J for vector B, negative 2. So plus the coefficient of plus 4 times negative 2. Now, A dot B equals to 3 times 6, 18, plus. Now here, remember 4 times 2 is what? 4 times negative 2, negative 8. Negative times positive, you are going to have negative 8. So that means A dot B equals to 8 minus 18, 10. You say 10 units, all right? 10 units. As you can see, we have, after we multiply 2 vectors, the answer that you get is a real number. So this real number is called a scalar product. So a dot product is called a scalar product because when you multiply two vectors, the answer that you get is a real number, constant number. As you can see, we don't have 10i or 10j or 10k. We only have 10 units to show that this is a real number. Hope you understand now. All right. So to find dot product of two vectors, you just multiply the coefficient of I alone plus the coefficient of j alone. All right. So that's how you tend to deal with the dot product. Now, there is also another formula which you need. There is also another formula that you need to learn. Dot product of a vector is also given as A dot B equals to magnitude of A times magnitude of B cos theta, right? So the same question that we had, all right? The same question that we had. So when do you use dot product? How can you use dot product? What do we use dot product for? We use dot product to find the what? The angle. Sometimes you can use dot product of two vectors to find the angle. So sometimes they ask you to say, find the angle between vector A and vector B. All right? Find the angle between vector A and vector B. So let's say vector A is 3i plus 4j. Vector B is 6i minus 2j. All right? Now the question is, find the angle between A and B. That is the question. Find the angle between A and B. So to find the angle between two vectors, get me clear here. To find the angle between two vectors, you need to use this formula here. Right? Always remember this formula. What you are seeing here, right? What you are seeing here, they mean magnitude. All right? These two bars, they mean find the magnitude. And remember what I said about magnitude. Magnitude equals to the square root of x square plus y square. All right? If you have three components, you say plus k square. So that means let's find the magnitude of what? A and the magnitude of what? B. Right? Let's find the magnitude of A and the magnitude of B. That's what you are going to do. So the magnitude, so first of all, we need to know the dot products A and B. So to find the dot product of A and B, we multiply the coefficient of I plus the coefficient of J, which we did, we find it to be what? A dot B was what? A dot B was what? 10, all right? Now let's find the magnitude of A and the magnitude of B, right? So I'm going to find magnitude of A. So magnitude of A equals to what? X square plus y square. So what is the x component of A? It was 3i. Remember, I means what? X. So 3 square plus, what was the component of y? It was 3i plus 4j. So j means y. So you get the coefficient of j, you square it. All right? So that means 3 square is 9 plus 4 square is 16. And 16 plus 9, you are going to have 25. And the square root of 25, you are going to have 5. All right? So this is the magnitude of A, 25. Let's find the magnitude of what? Magnitude of B. So magnitude of B equals to the square root of what? X square plus y square. So B was 6i, plus minus 2j, so 2 square. So the square root of 36 you know, 36 plus what? Plus 4. And that means the square root of what? 40. So now, since we have the magnitude of A and magnitude B, and the question is find the angle between two vectors. So that means to find the angle between two vectors, we are going to use A dot B equals to magnitude of A times magnitude of B times cos what? Theta. We are looking for the angle. So A dot B we found is to be what? 10. All right? So 10 equals to what is the magnitude of A? It gave us 5. Times the magnitude of B, it gave us a square root of what? 40. Times cos what? Cos theta. Remember, we are looking for angle. So that means we can divide over 5 to get rid of that. All right? So that we have 2 equals to the square root of 40 cos what? Cos theta. So there we can divide by square root of 40. Also here square root of 40. Right? So that now we find cos theta equals to 2 over square root of what? 40. So here, let's find the inverse. Let us find now the inverse. Let us find the inverse of that. So to find theta, you are going just to say theta equals to cos inverse of what? 2 over the square root of what? Square root of 40. So whatever answer you are going to find, that is the answer. So this is how you deal with dot products. So this is our first introduction. If you don't understand, please make sure that you go through.